Aggregate objects can be described by having a has-a relationship, as in a car has a steering wheel or a computer has a hard drive. Obviously, a car is comprised of more than just a steering wheel, as it also has an engine, a transmission, an oil pan, etc. Similarly, a computer has more than just a hard drive, as it also has a CPU, a fan, a power supply, etc. Therefore, both a car and a computer can be described as being aggregations. We can see that the Webster's Dictionary definition of aggregation is a group, body, or mass composed of many distinct parts or individuals. And if we look at what aggregation means in relation to computer programming from a website called computerhope.com, we can see the third definition says it is a type of object composition where not all the containing objects should be destroyed when the owning object is destroyed. What that means is that an engine object can exist before a car object is created, and if the car object is destroyed, the engine object can still exist. And a hard drive can exist before a computer object is created and will continue to exist once the computer object is destroyed. Thinking about these in terms of a real world example, it is true that before the manufacturing of a car is complete, it is highly likely that all the individual parts that make a car will be assembled as independent objects before they are all brought together to be assembled as a finished car. And should something happen to one component of the car after it is completely assembled that renders the car undrivable, such as the oil pan gets cracked, making the car unable to retain oil, all the other parts can be removed to be used in another car, or you could replace the cracked oil pan with another. In terms of the computer, the hard drive, CPU, fan, and power supply will all be created and assembled before they all come together in building a working PC. And should one component go out, the remaining components can be removed to be used on another computer, or the component that goes out could simply be replaced. The beauty of creating the individual components independently of the aggregate objects maximizes efficiency of the build process, and being able to reuse the components should the aggregate objects stop working maximizes the usability of them. Imagine if an engine was built inside the bay of a car while working around the build of the transmission or any other part. Or imagine if an entire computer was completely unusable simply because a USB port became damaged. Both these cases would lead to very inconvenient circumstances. Aggregation in the Java programming language and in object-oriented programming languages in general eliminates this inconvenience. Let's look at an example to see programmatically what I just described. In this example, the aggregate object will be a stringed instrument. The string instrument can be a guitar, a ukulele, a banjo, or any other stringed instrument. And since this is a string instrument, it will obviously have instrument strings. Therefore, this example will contain two classes in addition to the class that will contain the main method. The first class we will look at will be the instrument string class. Now, if you know anything about strings for a stringed instrument, you know the various strings of a stringed instrument have different gauges. This is what gives each string its own unique tone. So this class will contain one int variable to hold the gauge of each instrument string object that will be instantiated. The constructor will set the gauge, and the toString method will return the gauge. That is all the instrument string class will contain. Next, we will look at the string instrument class. This will be the class that creates aggregate objects. The objects created from this class will be aggregate objects because they will be composed of instrument string objects. And as we will see in a bit, the instrument string objects can exist whether or not a string instrument object is using them. Alright, so this string instrument class will contain three variables. The first will be a string variable to hold the name of the instrument. It is called name. The next variable will be an int variable that will store the number of strings that the instrument will have. It is called numStrings. And the last variable will be an array of instrument string objects. This class will contain three methods. The first is the constructor, which will assign a value to the string variable name and the int variable numStrings. After numStrings is assigned a value, it will be used to give the strings array a set size. The next method will be used to print the gauges of all the strings of the string instrument object. This will be done by utilizing the toString method of the instrument string object through a for loop. And the toString method will simply print the name of the string instrument and the number of strings it has. Alright, now let's utilize these classes in the main method. The first thing we will do is instantiate instrument string objects. We will instantiate 7 of them. They will be named string 1 through string 7. The gauge of each string will be initialized by utilizing the constructor of the instrument string class. As you can see, string 1 will have a gauge of 1, string 2 will have a gauge of 2, and so forth to string 7, which will have a gauge of 7. Note that these instrument string objects are being instantiated outside of any string instrument object's existence. Let's go ahead and create a string instrument object now. This object will be assigned a name of guitar, and it will be assigned 6 strings. Next, we'll go ahead and assign values to each of the 6 strings. For simplicity, the strings will be assigned gauges 1 through 6 in sequential order. At this point, we can see that the string instrument object guitar is an aggregate object, as it is composed of 6 individual instrument string objects. We can utilize the toString and print gauges methods of the string instrument class to see that we did indeed create an object named guitar with 6 strings, and the gauges of the strings are 1 through 6. Now, to further demonstrate aggregation, we can create another string instrument object that will be named ukulele that will have 4 strings. We can reuse the instrument string objects in order to equip the ukulele with strings having gauges of 1, 3, 5, and 7. And if we utilize the toString and print gauges method of the ukulele object, we can see that we successfully created a string instrument object called ukulele that has 4 strings. And we also successfully assigned the gauges of the 4 strings as 1, 3, 5, and 7. If we delete the string instrument object guitar and also the method calls associated with it, we can see that nothing is affected regarding the instantiated instrument string objects. In fact, we can also get rid of the string instrument object ukulele and the method calls associated with it, and by utilizing the toString method on the instantiated instrument string objects, we can see that they are all still fully functional, independent of any aggregate object that would utilize them. As with the real-world example of aggregation mentioned at the beginning of this video, the abilities displayed in this programmatic example also support maximum efficiency in the development process, as well as maximum usability or reusability of code.